Okay, today we are going to talk about section 6.2. Before we talk about 6.2, we need to review some things from chapter 5, and that is factoring, because you will need to factor in some of your problems today. If you have something in this form, you need to remember that it factors to a plus b quantity squared. If you have something in this form, it factors to this. If you have a to the third plus b to the third, factors to the quantity a plus b times the quantity a squared minus ab plus b squared. A to the third minus b to the third, it factors to a minus b, the quantity a minus b times the quantity a squared plus ab plus b squared. And lastly, probably the one you'll use the most is the difference of perfect squares. Now this does say a to the second minus b to the second, but it could be a to the fourth minus b to the fourth. It would just make it a squared. A to the fourth minus b to the second would just be a squared plus b squared times a squared minus b squared. Okay? It's the difference of perfect squares. We need to be able to factor that. Okay, this is just an extension of this. Everyone probably, Miss Kenny, if you could press pause and allow everyone to write this down and then press play again. Okay, on to stuff from today's section. What we are going to do is we're adding and subtracting rational expressions. It's important to know that when you are adding and subtracting fractions, the main thing you need to find, a common denominator. Okay? Got to have that. If I was to add these two, if I was to add 1/3 plus 1/6, I could not add these two right now. Reason being, my denominators are not exactly the same. So what would I do? Well, I would need to multiply this one by 2 to make it to a 6. But the thing about it is I can't just decide to multiply that by 2. I can't change anything. I don't have to change this one. If I multiply the bottom of a fraction by 2, I then have to multiply the top by 2 and keep the fraction the same ratio. So this becomes 2 over 6 plus 1 over 6, making this become 3 over 6, which is 1/2. One other thing I also want to go make you aware of, and then how we'll do a lot of our problems. Some of you may not have seen fractions done like this. You should have. But you'll find that in your high-level math, this is just a more efficient way to do it. Instead of writing two denominators again, when you get a common denominator, it's basically one big fraction where the bottom is 6. I multiply the bottom by 2, and I multiply the top by what? 2. So this becomes 2 plus whatever was on top there. And as you see, we get the same answer, and we have to write down less. But that's how we'll do these, because we'll get some kind of messy looking answers, and it's more cleaner if you write it like that. We all should know how to get common denominators. We should have all done that before. What we're doing new here is when you get something like this. How about x squared y over z plus x squared y over z? What in the world will we do here? Well, the first thing you ask yourself is, do you have a common denominator? And if you look at the bottom of these fractions, you do. Okay? There is a z at the bottom there. It's the same, so I can make it into one big fraction, then at the top have x squared y plus x squared y. Don't worry about adding these yet until you make it into one big fraction. Then once you've done so, and you don't have to worry about the denominator anymore, worry about one thing at a time. Now look and see if you have like terms. And as it turns out, you do. 2x squared y over z. And there's nothing else to simplify, so that is your answer. One thing I'd like to add about these videos is I would like all of you to watch me do each problem. Then Miss Kenny, after we're done with the problem, we'll press pause. Everybody write it down, and then she'll just press play. Okay? Third problem. What happens if we have something like this on the bottom? 5 over x plus y in parentheses plus 6 over x plus y. As far as simplifying, you need to be leery of simplifying when you have what? plus signs and minus signs on the bottom. But the beauty is, if your denominators are the same, you can make it into one big fraction. Notice I did not multiply these together. It's just we have a common denominator, so you just make it into one big fraction. What's left to add? 5 plus 6. The answer here, 11 over x plus y. There's your answer. Easy peasy. Pause if you need to. Number 4. Now, what are we going to do when we don't have a common denominator? Example. This is actually an example from your assignment you're going to have tomorrow. A squared over c, a squared b squared over c plus b squared d squared over c squared. Another key thing to remember, trust me, a lot of times your answers are not going to be pretty. It's okay. Okay, first things first, do I have a common denominator? Can I make this into one big fraction? I can't, because even though they both have a c, one is c squared as one is c. Now comes when you have to say to yourself, how can I make the smaller, or one of these are going to be able to multiply something by it and make it the same as the other. If you think about it, what would I need to multiply c by to make it into a c squared? The answer, c. If I multiplied this by c times c is c squared. Everyone agree with that? It's no different than when we decided, hey, if I multiplied 3 by 2, I could make it into a 6, couldn't I? That's what you went through in your head there. Here you're saying, how can I make a c into a c squared? Well, c times c. And the same rule also applies. If I multiply the bottom by 2, I had to multiply the top by 2. Same thing here. If I multiply the bottom by c, I have to multiply the top by what? C. Now, I didn't have to change anything over here, so it stays the same. So now, we'll write down the things that stayed the same. A squared, b squared, but what did we multiply the top by? We also have a c up here now. All of that plus b squared, d squared over c squared. Now, do we have a common denominator? We do, so we can make one big fraction. Don't worry about how these add together yet. Just write this addition problem up here, or subtraction. A squared b squared c plus b squared d squared. Now, look at that ugly mess up there. Yes, it's ugly, but guess what? They're not even close to like terms. So can you add them? No. You're done. Heck, when they come out ugly like that, in a way, they're easier. Okay? Pause if you need to. Number 5. How about mn squared over xy plus mn squared over x squared y squared? Do I have a common denominator? I do not. But you ought to be able to look at this and say, hey, you know what? If I had multiplied that x, like if I multiplied that times x, wouldn't x times x give me an x squared? Everyone agree? So that'd be part of what I need, right? But also, if I multiplied it times that y times a y, I'd get y squared. So you can see that if I multiplied the bottom times x and times y, I'd get x squared, y squared, which would give me what? Common denominators. But if I multiply the bottom by x and the bottom by y, I have to multiply the top by x and the top by y. So as a result, I am now left with mn squared xy on top. On top of this one, I'm left with mn squared. Now, I admit that is one big ugly looking fraction. But our bottoms are the same, so now I can make it into one big fraction. Mn squared xy plus mn squared. Are those like terms? They were like terms, but now that the xy's on the end, they're not. Guess what? You're done. It's not pretty, but it's right. Now, I mentioned the factoring. The reason I did is you'll find that it's easier to see what to multiply by they've set some of these up to where if you factor them, it'll be easy to see what you need to multiply the top and the bottom by. Great example of this is one like this. L plus m, L squared minus m squared, plus L minus m over L plus m. Now, if you look at this right now, you're probably going to be, how in the world am I going to get a common denominator? Obviously, they're different. I just can't square both of those and make it into a minus. And when you get one that looks weird like this, okay, realize there's probably some factoring to do. So get your little list out of your quick factors and see if any of them fit. Obviously, this doesn't look anything like this one, does it? Doesn't look like that one. Starting to look like that one, except that one's to the third, right? Starting to look even more like it with the minus, but it's also to the third. But then you get to the bottom, basically you have the difference of perfect squares. And anytime you do, it's plus minus, square root of that, square root of that. So I can factor this using this. I could factor the bottom here to L plus m times L minus m. Now, is it supposed to pop in your head exactly what to do right now? No. Rewrite everything, and look what you now have. And tell me if it all of a sudden looks easier to find and get a common denominator. If you look at the denominators, now they have something in common. Where up here it looked like they just had L's and M's in common. Now there's an SM here and an LM here. But also times we're missing that over here. But the nice thing is, I could just multiply the bottom by L minus M, and would they now look exactly alike? They would, wouldn't they? It's no different than what you were doing. What? Top by the exact same thing. So as a result now, by multiplying the bottom by L minus quantity, L minus M, you notice we have exactly the same denominators. So as a result, we can make this into one big fraction where it's M on the bottom. What is now on top? L plus M quantity plus, well, L minus M times L minus M. That's an M. Pretty much you're done. I know you want to look at this and say, hey, I can cancel out. You can't cancel when there's a plus here. The only thing you can do to simplify this a little bit more is to say L plus M plus L squared over L plus M times L minus M. That is a very ugly answer. I don't know, it's actually kind of pretty because it took a lot of work to get to there. Once we factored it, it was easy to see what we were missing to make common denominators on the bottom. Won't be a bunch like this, but there will be some. The book will have you multiply these out and simplify. At this point, I don't want you to do that, okay? I want you to leave it just like this. And then when I get back, we'll go back and do this, and we'll talk about multiplying these back out. How about one like this? Quantity squared over 1 minus y minus x minus y quantity squared. And is now we're subtracting. I'll let you know a little secret. If we're going to leave it in this type of form, really the only difference you're going to have at the end is probably have a minus here instead of a plus. However, b would be 5. Now think about it. I know it's tough, but 1 is a perfect square. Isn't 1 times 1, 1? So we have the difference of perfect squares. So this becomes 1 minus y minus, now I could factor this to 1. It is now broken down a little easier to see what we're missing. The denominators look much more, or much closer to being possible for them to be the same. I have the 1 minus y, 1 minus y. I just need to multiply it by a what? And on the top would be left with what? 1 plus y, x plus y, quantity squared, minus x minus y, quantity squared. These are not like terms. Write problems, show all steps and work. This is on section 6.2. Please try.